Good day everyone, here's our math challenge for today. And here's our question. Given these four circles, wherein these two green circles are congruent, and the length of the radius of this red circle is 1 unit, then the question is, what is the length of the radius of these green circles? Now, if you want to try this problem, just pause this video. We have 20 seconds. And timer starts now. And time's up. Now let's answer this question together. To answer this kind of question, what we're going to do is to consider always the center of the circle. So we have the center of this green circle, the center of this large circle, and the center of this red. So let's put the center of this green circle. Now what we're going to do to these centers is, of course, connect them. Now we know that the length of the radius of this green circle is denoted as r. Therefore, these four radius must be equal to r. And on this red circle, take note that the length of the radius must be 1. Therefore, these two radius must be also equal to 1 because all radius of the circle are congruent. Now at this point, let's draw its height like this. Since this segment is the height of this triangle, therefore it is perpendicular to its base. Now this part of the height of the triangle measures 1. The reason is it is also the radius of this red circle. And the remaining segment of the height of this triangle, let's call this as x. Now let's consider this right triangle. Now since we have a right triangle, we can use the Pythagorean Theorem. So we have r squared plus 1 plus x squared equals 1 plus r quantity squared. Now we have an equation with two unknown variables. So to solve them, what we're going to do is to find another equation having these two variables. So let's go back to our previous figure. Now, from the center of this big circle, let's draw a radius pass through the center of this green circle like this. Now let's consider this right triangle. From this figure, we know the length of the legs of this right triangle. Now, how about the length of the hypotenuse of this right triangle? Now, notice that the length of the radius of this big circle must be equal to 2 units. Alright? Now, we know the length of the radius of this big circle must be 2. And also notice that this segment is the radius of this green circle, which is equal to r. Therefore, the length of the hypotenuse of this right triangle must be equal to 2 minus r. Now at this point, we can now use again the Pythagorean Theorem. So we have r squared plus x squared equals 2 minus r quantity squared. Now we have two equations and two unknown variables. So we can now solve for the value of r. Now let's focus on these two equations. From here, let's simplify first the first equation. So 1 plus r quantity squared will give us 1 plus 2r plus r squared. Now notice that if we subtract r squared on both sides, this r squared on the left hand side and on the right hand side cancel out. So what we have now is 1 plus x quantity squared equals 1 plus 2r. Now get the square root on both sides. So the left hand side of our equation becomes 1 plus x equals square root of 1 plus 2r. Solving for x, we get that x must be equal to square root of 1 plus 2r minus 1. So let's set aside this result. Now let's get the second equation. So we have r squared plus x squared equals 2 minus r quantity squared. Now let's simplify the right hand side. This is equivalent to 4 minus 4r plus r squared. Again, if we subtract r squared on both sides, r squared on the left hand side and on the right hand side cancel out. So we have x squared equals 4 minus r. Now get the square root on both sides, and the left hand side of our equation becomes x, and it is equal to square root of 4 minus r. Now take note that this is both equal to x. Therefore, we can say that square root of 1 plus 2r minus 1 equals square root of 4 minus 4r because they are both equal to x. Now what we're going to do here is to solve for r, and that's our goal. So first thing to do is to square on both sides. Now the left hand side of our equation becomes 4 minus 4r. And the left hand side of our equation becomes 1 plus 2r minus 2 times square root of 1 plus 2r plus 1. Now, 1 plus 1 will give us 2. Subtract 2 on both sides. Now, subtract 2r on both sides. So, our equation now becomes negative 2 times square root of 1 plus 2r equals 2 minus 6r. Since all numerical coefficients are even, so we can divide this by negative 2. If we do that, we get square root of 1 plus 2r equals negative 1 plus 3r. Now, negative 1 plus 3r can be written as 3r minus 1. Now, at this point, let's square again on both sides. Thus, the left-hand side of our equation becomes 1 plus 2r, and the right-hand side of our equation becomes 9r squared minus 6r plus 1. Now, subtract 1 on both sides, 1 on the left-hand side and 1 on the right-hand side cancel out. So we have now 2r equals 9r squared minus 6r. Subtract 2r on both sides, so we have 0 equals 9r squared minus 8r. From here, let's factor out r. So we have 0 equals r multiplied by 9r minus 8. Since it is equal to 0, it follows that at least one of them must be equal to 0. So we can say that r equals to 0 or 9r minus 8 equals 0. Now we know from the figure that r cannot be equal to 0. Therefore, we can solve the value of r using this remaining equation. So add 8 on both sides. So we have 9r equals 8 divided by 9 on both sides. So we get that the value of r must be equal to 8 over 9. Therefore, we can say, given this figure, that the length of the radius of this green circle must be equal to 8 over 9 units. And as always, we are done.